Hi there, it's been an interesting journey learning trigonometry, and this is actually the last lesson on it. Get a copy of Brilliant Math Module 6 from brilliantmath.com and let's go to class. In this part of the lesson, we want to look at application of trigonometry. We're looking at angle of elevation and depression. What is an angle of elevation? An angle of elevation is the angle your line of sight makes with the eye. Assuming you're looking up, the angle between your eye and the horizontal line of sight is your angle of elevation. Just like we have here. Alright, I'm standing here and then I'm looking up. So that angle is the angle of elevation. While the angle of depression is the angle it makes, the line of sight makes to the point you're looking down at. Same position, we're coming down. So that's the angle of depression. Alright? Let's look at an example. From the top of a cliff, 19 meters high, Cynthia sees a boat at sea. The angle of depression from Cynthia to the boat is 73 degrees. How far from the base of the cliff is the boat? The first thing you need to do is sketch the information that you have. So let's say Cynthia is here, that's her eyesight, and she's looking at the boat at sea. So she is on top of a cliff. So that's the angle of depression. There are two ways you can do this. So that's the angle of depression. It's a right angle triangle. So there's a right angle there. We want to calculate the distance between the base of the cliff and the boat. It's either of two things. If we're going to use, let me call this triangle X and triangle Y. If we're going to use triangle X, our angle of depression is 73 degrees. This height, the height of the cliff, is the same here. It can be represented there. That's 19 meters. So that tan 73 degrees is the opposite over the adjacent. This line measures the same as this. So we can represent this by X. They are equal. So the opposite, which is 19 meters, over the adjacent to the angle of depression. So we have tan 73 degrees is equal to 19 over X. So to find X, which is that distance, we'll cross multiply and make X the subject. So that X is equal to 19 over tan 73 degrees. Put that into your calculator. 19 divided by tan 73 degrees. And what do you get? You get 5.8 meters. So X is equal to 5.8 meters. But an alternative method is to find this angle. And how can we calculate that angle? Since this is a right angle, subtract 73 from 90, and that gives you 17 degrees. So that angle is 17 degrees. Therefore, again, 17, we have the opposite and the adjacent. So we can say that tan 17 degrees is equal to opposite, which is X, over the adjacent, which is 19 meters. So to find x, we cross multiply. We multiply 19 by tan 17 degrees. So we put that into the calculator. We have 19 times tan 17 degrees. And what do we get? We get 5.81. So approximately that is 5.8. So any of the methods you use, you should get the same answer. But know that your angle of depression is the angle that the line of sight makes with your eye as you look down. That is your angle of depression. And the angle of elevation is the angle your eye makes with the line of sight as you look up. That's just the only difference. And you have two methods or two ways of calculating it. Try it out. You'll surely understand. In this part of the lesson, we want to look at introduction to bearings. Bearings is a very interesting topic, so pay attention and let's work together. State the bearing of point P in each of the following diagrams. Bearings are just directions, all right? And there are a few points you need to know about bearings. They are written in 3 digits. And bearings are clockwise from the North Pole. So it goes clockwise from the North Pole. You also need to know the 4 cardinal points, the 8 cardinal points to be able to work with bearings. The 4, north, east, south, and west. And then where you have the northeast, southwest, and all of that. You need to know the cardinal points. So please go learn them. If you don't know them, get a copy of Brilliant Maths Module 6. You have lots of examples and introductions in it. So state the bearing of point P in each of the following diagrams. So we have that diagram. From the North Pole to P is 48 degrees. So the bearing of point P, the bearing of P is equal to 048 degrees, because you write bearings as 3 digits from North Pole to the point where it goes to P. So for B, the bearing of P is equal to, here we have 60 degrees between south and west. So you have to find the sum of all the angles to that point. That will be the bearing. So 90 plus 90 plus 60. So 90 degrees plus 90 degrees plus 60 degrees. 90 plus 90 is 180. And 180 plus 60 will give you 240 degrees. So the bearing of point P in this diagram is 240 degrees. For C, we have 40 degrees between the south and the east point. So what will be the bearing? Remember, it is clockwise. So it's the sum of all the angles. That's the first quadrant. Or rather, let's say that angle is 90 degrees. And this is another 90. So if this is 40, then this is 50 degrees. So the bearing will be 90 degrees plus 50 degrees, making it 140 degrees. The bearing of P is equal to 140 degrees. And then finally, we have P between north and west, and that is 20 degrees. The sum of all the angles going clockwise, that's 90 plus 90 plus 90, giving us 270 degrees plus 20. So the bearing of P is 290 degrees. So 90 plus 90 plus 90, making it 70 plus 20, and that gives us 290 degrees. So it's very easy. All you need to do is know your cardinal points and be able to do the additions. All right. Next, we are going to look at drawing out the bearings without the cardinal points. Let's look at more examples. North pole, and clockwise 65 degrees is thereabouts. It's just a sketch. All right. So that is 65 degrees. This is a right angle, so the other side left will be 25 degrees. Take note of that and take your time to sketch it out. A from B. So this is our A coming from B. What do we remember about alternate angles? If this is 65 and that is 25, remember that alternate angles give us a Z shape. So the top here is 25 degrees and here is 65 degrees. So now we can easily find the bearing of, what is the bearing of B from A? So we now want to find the turning. If it's coming from A, what will be the bearing? From North Pole, we go clockwise all the way to that point. So the bearing of B from A, remember it's coming from A, the first quadrant 90 degrees, then we have another 90 degrees, and then before 65 degrees where it goes to B. So that will be equal to 90 degrees plus 90 degrees plus 65 degrees. 90 plus 90 is 180, and 180 plus 65 will be 245 degrees. So the bearing of B from A is 245 degrees. Very interesting. So in this next example, a ship sails from X to Y on a bearing of 120 degrees. On what bearing will it have to sail to return from Y to X? So we look at the sketch here. It sails from X to Y. From where it's coming from is X. And that is 120 degrees going to Y. What bearing will it have to sail to return from Y to X? And that's the North Pole. So this is very easy. It's either of two ways. Who can remember how to find the angle Y? What are the properties? What's the relationship between angle 120 and angle Y? These are parallel lines because these are the North Poles. They are supplementary. They are co-interior angles, so they add up to 180. So Y is actually 60 degrees. So you can simply calculate the bearing. It has to return from Y to X, from Y back to X, by just going from the North Pole all the way there. So if this is 60, then that bearing is 360 minus 60. As you can see, that's easy. Or, alternatively, you can also extend that line so that you get your angles. That is 120, and that corresponds to this angle. So that means that this angle is 120 degrees. And if that angle is 120, this is 180 degrees because it's an angle on a straight line. So that's 180 degrees. And if we add 120 plus 180, that gives us 300 degrees like we got the first time. So the bearing of X is equal to 300 degrees. Take your time to get more practice. And you can get a lot of practice from Brilliant Maths Module 6. Get a copy from brilliantmaths.com. We are still looking at bearings, but this time we want to look at the application of sine and cosine rules using bearings. We have an example here. You really need to pay attention for you to understand. It says 3 towns, A, B, and C, are situated so that AB is equal to 60 kilometers and AC is equal to 100 kilometers. That's the distance from A to B and the distance from A to C. The bearing of B from A is 60 degrees. That's 060 degrees. And the bearing of C from A is 290 degrees. Calculate A, the distance of BC. That's the distance of B from C. And then calculate the bearing of B from C. I'd like to sketch this out and then we work through the solution. The sketch is very important. So, ABC, we have the bearing of B from A. So, the starting point is A. So, that's our A. The bearing of B from A is 060 degrees. So, it's here, kind of. Going up. This is 60 degrees. 060. And that distance, let it go up a bit. That distance is what? And this is B. AB is 60 kilometers. Very good. And the bearing of C from A is 290 degrees. So from A again, 290, 270 is there, and then we cross in 20 degrees. So that's our C. That's point C. So we have that bearing is 290. That's 270 plus 20. So how many degrees do we have in here? We can actually use a sketch to get this angle. So if that is 290, then this angle is 70 degrees. You can either look at the quadrant there, 90 minus 20 to get your 70, or 360 minus 290, which will also give you 70 degrees. So the angle here is 130 degrees. And the distance from A to C, AC is 100 kilometers. What are we supposed to find? BC and the bearing of B to C. So when we join this line, is a sketch. When we join the line, we no longer have the angle. The only angle we have here will be 70 using our alternate angles. So that is 70 degrees. But we don't know this angle. So we have to find this angle in order to be able to find the bearing from C, the bearing of B from C. So that's actually this. We need to find that. So first and foremost, we have to find the distance BC, x. To find BC, we need to use the cosine rule. The sketch makes it look as if it's a straight line, but it is not. All right? Take note of that. It is not a straight line. Because it's a sketch, it looks like a straight line, but it is not. So to find x, if this is our A, that's angle A, so that side is lowercase letter a. That's our angle B, so this will be our lowercase b, and then that will be our lowercase c. So using the sine rule, we have that a squared is equal to b squared plus c squared. So that's 100 squared plus 60 squared minus 2bc, that is 2 times 100 times 60 cos 130 degrees. So x squared, which is our a, is equal to 100 squared plus 60 squared minus 2 times 100 times 60 times cos 130 degrees. You can put that straight away into your calculator and you'll find that the value of x, which is the distance of BC, is equal to 119.87 kilometers. Very important. So we have found that distance. So having found that, the next is to find the bearing of B from C. So to find BC, we will use the cosine rule. A squared is equal to B squared plus C squared minus 2BC cos A. We have our angle A, which is 130 degrees, and our side A, which is X. The unknown side we are told to find, which is our BC, the line BC. BC is not a straight line, this is just a sketch, because we are also going to find the bearing of B from C. So take note of that. So first we need to find A or X. So x squared is equal to 100 squared plus 60 squared minus 2 times 100 times 60 times cos 130 degrees. 100 squared is 10,000. 60 squared is 3,600 minus 2 times 100 times 60 would give us 1,200, because 100 times 2 is 200 and 200 times 60 is 1,200 times cos 130 degrees. So to find x, it's going to be the square root of all of that. To use your calculator, please punch correctly. 100 squared is 10,000 plus 3,600. You have to put them in a bracket if you want to find the square root straight away. Put that in a bracket minus 1,200 times cos 130 degrees. So punch correctly and let's do this together. So x is the square root. We are punching correctly. So make sure you punch correctly. So we have square root, put a bracket, 10,000 plus 3,600. So you close your bracket and then minus bracket 1,200 times cos 130 degrees. You close your bracket and then you close the final bracket, and what will you get? It will give you x is equal to 119.87 kilometers. So that is the length of BC. So we have answered the first question. So next, we are supposed to find the bearing of B from C. So to find the bearing of B from C, we need to find this angle. We'll find that angle and then add it to 70 degrees. Then subtract that sum from 180 to give us that little turn there, the bearing of B from C. So to find this angle, we can now use the sine rule because we have the side opposite that angle, and we also have length BC, which is opposite the angle 130 degrees. You see how easy it is. So again, write the formula. I always encourage you to write your formulas before you use them. I wrote the cosine rule before I used it, and now I have written the sine rule before using it. Writing it helps you to learn it and own it quickly. So sine A over A, the ratio is the same if you use the angle over the line or the line over the angle, as long as you are consistent. So I'm using sine A over A is equal to sine B over B, and that's equal to sine C over C, because I am finding an angle, sine C, so that's on top. I don't need to divide. But you can also use A over sine A is equal to B over sine B, and that's equal to C over sine C. So we have sine 130, and we have the line 119.87. That's a complete ratio that we have. So we put that in, which is sine A over sine A. Sorry, which is sine A over A. So that gives us sine 130 over 119.87. And then sine C over C, we have to find angle C. But the line C is 60 kilometers. So those are the two ratios that we're using. So when you simply multiply 60 by sine 130 degrees and divide by 119.87, you will get sine C. So the sine of angle C is equal to 0.3834. Please put that into your calculator to make sure. So sine C is equal to 60 times sine 130 degrees, and then divided by 119.87, which is 0.3834. So to find angle C, you find the sine inverse. So shift sine inverse of that, and that will give you 22.55 degrees. So that is angle C. So the angle at C here is equal to 22.55. So to find that bearing, like we said, we add 22.55 degrees to 70 degrees and then subtract from 180 degrees. And when you do that, 180 minus that sum, put it into your calculator, 180 degrees minus 92.55, and that will give you 87.45 degrees. So that means that the bearing of B from C, the turn it makes from C to go to B, is 87.45 degrees. We have solved that question, and there are many more that you can find. Trigonometry in 3 dimensions is the next, but you can find that from Brilliant Maths Module 6. So go get a copy of Brilliant Maths Module 6 and practice, practice, practice. Hi there, I hope you enjoyed the lessons on trigonometry. I absolutely loved it. Subscribe to brilliantmaths.com. Get a copy of Module 6. There are several resources there for you. And don't forget to follow us on all our social media handles. My name is Ngozi Orevogini, and always remember that maths is fun and you can excel in it.